Hi, everybody. It's Brandon Doherty, Delaware Weather Guy, and this is the third installment in my tutorial series. Um, and essentially, I will make another video describing how a hurricane forms, but I thought in this tutorial I would discuss with you the conditions in which a hurricane would ripen and become strong in some sections of the Atlantic and Gulf of Mexico, because we know that that's where you know the hurricanes usually trek across the South Atlantic, and then from there either turn north or go into the Gulf of Mexico or the Caribbean. So what I want to just show you, on this website is this website will show us, depending on how a hurricane tracks and the conditions in which a hurricane forms dictates, pretty much, the size and strength of a hurricane. All right, so let's basically go to where hurricanes form. And let's start with sea surface temperatures. And basically, hurricanes need waters that are greater than 25 degrees Celsius. So that's no less than 80 degrees Fahrenheit. So all the areas in brown are like very warm conditions or oceans, and the lightish, little yellowish areas are, you know, within range. So anything from this shade of yellow right here to the darkest, like a light brown, are ripe areas for hurricane development. So these are some of the factors. The biggest factor is sea surface temperature. Moisture is, of course, prominent because when the humid air is forced upward, clouds form and rain falls. So, and that's what hurricanes largely are. They're massive consolidated rainstorms. And then the final factor is wind. Okay, so winds, depending on how a hurricane grows, um, in places where, but it's the upper level winds that dictate if a hurricane stays kind of like just more of a tropical depression or becomes stronger. The more wind, and it's called wind shear. The more wind shear, um, hurricanes get, or storms get torn apart. Less wind shear, storms are available. The storms can grow. The storms can gather more moisture and deliver more rain, because really in the end, what dictates the severity of a hurricane and where the most deaths occur are because of storm surge. So that becomes, and the winds, those become the biggest factors here. All right, so let's start with sea surface temperature, and let's start all the way back here. Now, they usually form off the west coast of Africa. These sub-Saharan um, wind events, they blow, um, they develop these low conditions that form off the coast of Africa near the Ivory Coast here. Okay, so hurricane forms grows and is growing in size. It is in an area with just the right conditions. Moisture, it is in a good area for moisture, and the lighter wind shear here allows the hurricane to continue to grow and continue to trek across the Atlantic. So let's continue it. So again, wind shear is good conditions. We have just the right moisture, and it's good. It's in an area of good sea surface temperatures. Now the hurricane is growing because it's in much warmer waters. The moisture is plentiful, and the wind shear again is are calm, and so it's able to grow. Once it gets into the South Gulf, um, it continues to grow, or South Caribbean Sea, it continues to grow. These conditions are much warmer, much more hospitable, and again, it's sort of if it takes this kind of southerly track across. Now, this would be the uh, ideal track for a hurricane. Okay, this is kind of like southerly motion. So if it takes a pure, you east to west, east to southwest, east to southwest track, then the hurricane is more likely going to become a pretty intense storm. Usually, when a hurricane starts to turn north, okay, it starts to weaken a little bit. It's in an area of less humidity. Drier air is another um, enemy of hurricane growth and tropical storm development. And of course, it's in a stronger area, wind shear. But that doesn't, if there's a high wind shear, but continued moisture, then the hurricane's going to continue to develop. If sea surface temperatures are high, humidity is high, but the wind shear is strong, then the storm is more likely to continue to develop. Okay, so this is just another path when it generally approaches Florida. Now again, not ideal uh, wind or wind shear. Um, the moisture in this region is not um, ideal because it's starting to get into cooler waters, but again, can continue to grow. And we have had hurricanes on the eastern coast of Florida. Now, it's usually when tropical storms that form into hurricanes go across the peninsula or trek, sort of like over the Lesser Antilles into Puerto Rico through the Caribbean and the Bahamas and sort of just skirt the southern coast of Florida or go over the eastern, the southern southeastern coast and go into the Gulf. That's when trouble exists. Okay, and we know all about Hurricane Katrina. Uh, she formed into a behemoth, and she had all the right conditions. The wind shear was low, the moisture was rich, and the sea surface temperatures were high because you can see it's in this brighter area of brown that developed into category 4. Okay, now if you take something like Sandy, 2012, all right, it started out in high sea surface temperature areas and grew strong. It kind of went over Cuba and Puerto Rico and Haiti. Did some damage there. Then it got into the cooler waters of the kind of eastern northern Atlantic. And it actually started to degrade into a weaker storm. Okay. Wind shear was not hospitable for further formation. Moisture wasn't rich. It was late October, and the sea surface temperatures started to wane, to go down. Okay, so when Sandy tracked up to the east coast, what made Sandy into the behemoth that she was there was a low pressure dropping from the Midwest, and a trough sort of picked her up and brought her up to the coast. Now, and then the storm surge just went right into New York City. So everybody was waiting. Everybody was kind of hoping that Sandy would make the turn. Now, usually when a hurricane gets into this part of the Atlantic, it can still thrive as it's approaching the Florida coast, as explained. But once it starts to get into the Atlantic, it can't really survive much longer. And you'll see in some areas of the Atlantic, you'll see these X's. Okay, it can't further sustain itself. It turns into a extratropical low. So essentially, the best path for a hurricane to take is to keep this kind of like southerly southerly route, because then it keeps growing into it keeps it in a very favorable environment. It's when storms sort of get a little further. This is always the tricky area. This is a good area. This is a good area. This is a decent area. This is okay area. But once it starts going into or making that turn up further north, is when it starts to weaken a bit. But we have various factors like sea surface temperature, moisture, and wind shear that impact its development and sort of feed its growth or feed its demise. So that's about it in terms of what makes a hurricane stronger or what makes a hurricane weaker. Mostly the temperature of the sea, moisture in the air, and high winds all play a role. So if you go to this website, it's UCAR. Let's see, UCAR for Center for Science Education. Um, you can sort of play around with this and just see, um, the impacts these areas make, and what can define further growth and what can define further weakness. That's it for me, Brandon Doherty Dell, weather guy, saying adios.